Let's learn about geometric sequences. A geometric sequence is formed when each term of the sequence is obtained by multiplying the previous term by a fixed amount. Okay, so in arithmetic sequence we added or subtracted the values from the previous term. In geometric series it is multiplying. Okay, now let's take an example. Suppose if you have a number 2 and if you are multiplying it by 3, which is 6, then again multiplying it by 3, which is 18, again multiplying it by 3, you will get 54. So this forms a geometric series. So this is being increased by a factor of 3. Okay, you can also decrease it, like if you divide a number by a certain number, then you will get another geometric series. Okay, to generalize it, what I can say is like if the terms are t1, t2, t3, t4, t and tn, the first term is a. It's the same as that of the arithmetic sequence. Now second term, and if I'm multiplying it by r, second term is ar. The third term is ar times r, which is equal to ar square. Okay, so the third term is ar square, and the fourth term is ar to the power of 3, and it goes on like this, and nth term will be ar to the power of n minus 1. So the fourth term is ar to the power of 3. So that is why ar to the power of n minus 1. So what you have is tn is equal to the nth term of a geometric sequence is ar to the power of n minus 1. Okay. Now in the case of arithmetic series, it is a plus n minus 1 into d. Okay, so that's a difference which you have to remember, which you will distinguish between the geometric and the arithmetic series. Okay, and to find so what you have, a is equal to the first term and r is called the common ratio. Okay, the common ratio, why it is called a common ratio is because that is the value which you multiply the previous term so that you get the next term. So how will you find the common ratio? Common ratio can be found by dividing any two terms. Like for example, if t1, t2, t3 are there, you can either divide this by this or divide this by this. So it can be like t2 over t1, or you can do t3 over t2, or to generalize it, you can write tn divided by tn minus 1. So this is how you find r. Okay, so let me just do a comparison between arithmetic series and geometric series. So arithmetic series, you add or subtract a value, or maybe add a negative value. Here you multiply or divide, or instead of dividing, you are multiplying it by the fraction. Okay, and then the value what you do is called common difference in the case of arithmetic series, and here what you multiply or divide is called the common ratio. Okay, how will you find the common difference? Tn minus, so here you subtract it, tn minus 1. To find the common ratio, you do tn divided by tn minus 1. And what is the nth term in the arithmetic series? It is a plus n minus 1 into d. And in the case of geometric series, it is ar to the power of n minus 1. Okay, this is the difference between arithmetic and the geometric series. So let's try some questions out of this. So if the series, there's a geometric series 1 over 4, 1 over 16 and 1 over 64 and goes on like this, find tn. Okay, so to find tn, what you need to do, you have the formula ar to the power of n minus 1. In this case, a is equal to the first term, which is equal to 1. And how will you find r? R is t2 divided by t1, so that is 1 over 4 divided by 1, which is equal to 1 over 4. Any two terms, if you divide, you will get the value. So tn is equal to 1 times 1 over 4 to the power of n minus 1. This you can simplify this as 1 over 4 to the power of n minus 1. Okay, let's try a different question. If t3 is equal to 32 and t6 is equal to 4, find a and r. Okay, So T3 means the general formula. When you go with the general formula, AR to the power of 3 minus 1 is equal to 32, and T6 is equal to AR to the power of 6 minus 1 is equal to 4. So with this you can write AR square is equal to 32. Let that be there. And with the right one, what you can do is like AR to the power of 5 is equal to 4. So you have two equations here, 1 and 2, with the values AR square and AR to the power of 5 with some values. So now what you do is you can either divide these two, like for example you can divide 2 over 1, because it's all multiplication, there's no other way you can solve it. So what you can do is like AR to the power of 5 divided by AR square is equal to 4 over 32. So 2 divided by 1 is what I am doing. And here R square and R to the power of 5 will get cancelled. That will become R to the power of 3. A and A will get cancelled. So R to the power of 3 is equal to 1 over 8. So then R is equal to 1 over 8 to the power of 1 over 3, which is equal to 1 over 2. So you have gotten R. Now we have to find A. So AR square is equal to 32. So A times 1 over 4 is equal to 32. You are subbing in the value of R, and A is equal to 32 times 4, which is equal to 128. So R is equal to 1 by 2 and A is equal to 128. Similarly, we can do other problems also. We will come back to that. So before that, let us work on exponential series also. Exponential sequences. Sorry about that. It's not series, it is sequences. So exponential functions always take the form of y is equal to a to the power of x, where a is the initial value and a is the multiplier, or it is called the common ratio. Okay, now this is one form of geometric series, that is why we need to learn this. So now if you take the case of suppose a ball is dropping from the height, and if the ball is bound, like for example it is saying that a ball is dropped from the height and it's bounced to around 2/3 of its height at every turn, then you can write it as 10 times 2/3 to the power of 1. That will be the first one, and then the second bounce, it will be bouncing it to 2/3 to the power of 2, and third one it will be 2/3 to the power of 3, etc. So after n bounces, it will be 10 times 2/3 to the power of n. Okay, so this is how the exponential sequence works. This is also a part of geometric series, so we need to understand exponential, how to work with exponential series also. Okay, let's do another question on this. There are three numbers, n minus 2, n and n plus 3, which are three terms of a geometric series. Okay, find the value of n and write the series. So here the keyword are geometric series, and these are part of the geometric series. So if it is a geometric series, what is the criteria? Like if you have T1, T2 and T3 as part of the geometric series, what you can say is T3 divided by T2, this is equal to this T2 divided by T1. Okay, so now when we apply that to this, you can say that n plus 3 over n is equal to n divided by n minus 2. Now to work on this, what you can do is you can cross multiply. So it is n plus 3 times n minus 2 is equal to n square, and simplifying this, n square plus 3n minus 2n minus 6 is equal to n square. So n square will get cancelled. 3n minus 2n is equal to 1n minus 6 is equal to 0. So n is equal to 6. So this we found out. And if you need to write the series, what you can do is you just need to sub in the 6 to the value. So it is 6 minus 4 6 and 6 plus 3. So that is nothing but 2, 6 and 9. Okay, so this is part of the geometric series. Let me take another question. Okay, the product of 3 terms of a geometric series is, sorry, I cannot call this as a series because we are not adding the value. So geometric sequence is 27 and their sum is 13. Okay, so you need to find the first 4 terms of the sequence. Okay, so what they are saying is there's a product of the 3 terms of the series is 27 and their sum is 30. Find the first 4 terms of the sequence. Now how will we do that? So what we need to do is you need to form the geometric series here and then work with the geometric series geometric sequence rule and then find the values. So if you are taking the case of this, let me just take it as like let's work with A and R. Okay, so I'm taking the middle one as A. Okay, and so the previous one will be A divided by R and the next one will be AR. Okay, why I'm taking like this is just for my simplification, or what you can do is you can take it as AR and AR square. So AR and AR square. But I know that if I take it like this, the sum will be simple. Okay, so whenever you're working with geometric series and when you get some questions like this, it is always better to take like this so that our simplification will be much easier. Okay, now with this information they are saying that the product of the geometric series is 27. So product means A over R times A times AR is equal to 27. So this R will get cancelled. A cube is equal to 27. Now you might have gotten why I took this A and A over R. Okay, so we are getting a simplified version. Now the sum is 13. So which means that A over R plus AR is equal to 13, and I am simplifying this. So A plus AR plus AR square divided by R is equal to 13. Okay, and A plus AR plus AR square is equal to 13R. Now let's consider this first equation, A cube equal to 27. That means A is equal to 27 to the power of 1 over 3, which is equal to 3. So I got A as 3. So that I can sub in over here. So 3 plus 3R plus 3R square is equal to 13R. I can bring everything to the left side. So 3R square minus 10R plus 3 is equal to 0. And it is just normal algebraic simplification of factorizing. So 3R minus 1 and R minus 3, which is equal to 0. So 3R minus 1 is equal to 0 and R minus 3 is equal to 0. So 3R is equal to 1 and R is equal to 1 over 3, and here R is equal to 3. So now we have A is equal to 3 and R is equal to 3 and R is equal to 1 over 3. So there are 3 values. So the sequences can be written as A over R, A and AR. So that is 3. I'm just taking the case. Okay. So let me just write it for R is equal to 1 over 3. So we'll have to write it for both. Okay. Because we have 2 values of R, so you have to write it for both. So for the first one, 1 over 3, what you will do is 3 over 1 over 3 and 3 times 1 over 3. So that is equal to 9, 3 and 1. Okay, and it goes on like this. For R is equal to 3, you can write it as 3 over 3, then 3 times 3. So that sequence will be 1, 3, 9, it goes on like this. So these are the two sequences which follows this criteria. Okay, now let's work on one of the exponential one. So given Tn is equal to 8 into 3 over 4 to the power of n, write the first 4 terms. Okay, now to work on this question, what you do is, like, since it's given Tn, it is very easy. T1 is equal to 8 into 3 over 4 to the power of 1. So instead of n, you substitute 1, and then you put it into the calculator, simplify, and you will get the answer for 6. So for T2, what you do is you sub in the value of n is equal to 2, and then you simplify it, you will get 9 over 2. T3 is equal to 8 into 3 over 4 to the power of 3, which is, then when you simplify, you will get 27 over 8. T4 is equal to 8 into 3 over 4 to the power of 4. That you simplify, you will get 81 over 32. So this is mostly it. Let me see if I have any other generic question which I can explain it to you. Okay, no, this is it for the geometric sequence. We will see in the next video for geometric series.